Hello dear students, now today we are going to discuss basicity of amines. All amine compounds, it may be aromatic or aliphatic, are basic in nature. Now whenever we take the amine structure, formula of amine are RNH2. Now nitrogen of amine having a non-bonding electron pair and it has a tendency to donate electron pair. The substance which donate electron pair is known as a base, therefore amine compound are basic in nature and they are known as a Lewis base. Now suppose amine is allowed to react with the acid, hydrochloric acid. Then nitrogen of amine give electron pair to acid, H plus ion of acid. And as a result we get the salt RNH3 plus and Cl minus. So salt formation occur when base is allowed to react with the acid. So amine when allowed to react with the acid, it giving us salt. Therefore we can say that amine compound are basic in nature. Now we know that amines are of three types. When we take amine, then these amines are of three types. Primary amine, formula of primary amine is RNH2. Then second type of amine is secondary amine and tertiary amine. Now you are knowing very well what is the structure of secondary and tertiary amine. Now all it is observed that amines are more basic as compared to ammonia. Now ammonia is basic in nature because it has a non-bonding electron pair. Now when alkyl group attach with this, two hydrogen atom are replaced and alkyl group is attached. Then the alkyl group is electron donor group. Alkyl group having a tendency to donate electron pair. So it is observed that electron density will increase on nitrogen atom due to inductive effect. What is inductive effect? Suppose any species has a tendency to donate electron pair. It has a tendency to donate electron pair, so alkyl group donate electron pair to nitrogen. Therefore, electron density will increase on nitrogen. Therefore, we can say that ammonia is less basic as compared to primary amine, because as the number of alkyl group increase, electron density increase on nitrogen and it can donate easily electron pair. Therefore, this primary amine is more basic as compared to ammonia. Now, when we take the secondary amine, now secondary amine having a 2 alkyl group, therefore it has a 2 electron donor group and therefore electron density on nitrogen of secondary amine is more as compared to primary amine. Therefore secondary amine is more basic as compared to primary amine. And similarly, when we take a tertiary amine, formula of tertiary amine is R3N. You are knowing very well. Now this all three alkyl group having a tendency to donate electron pair. Therefore, it is observed that inductive effect is increasing. Inductive effect increasing because of this electron density on nitrogen will increase. When nitrogen having a more electron density, then it can easily donate electron pair. Therefore, we can say that tertiary amine is more basic as compared to secondary amine. Secondary amine is more basic as compared to primary amine, and primary amine is more basic as compared to ammonia. So, the basic strength of amine in a gaseous neutral state. In a gaseous neutral state, tertiary amine is more basic as compared to secondary amine. Secondary amine is more basic as compared to primary amine, and primary amine is more basic as compared to ammonia. Because as we go from tertiary amine to secondary, secondary to primary amine, electron density is going to decrease. As we go from primary amine to secondary, secondary to tertiary amine, electron density is going to increase. When more electron, then it can donate easily. Therefore, due to inductive effect, tertiary amine is more basic as compared to secondary amine more basic as compared to primary, and primary amine is more basic as compared to ammonia. So from this we can carry out common statement. First common statement, all amine are basic in nature. They are working as a base. Then we can say that aliphatic amine, all aliphatic amine are more basic. All aliphatic amine are more basic. Then aliphatic amine are more basic than ammonia. Now we have to discuss about aromatic amine. Now just I will remove this thing. Now when we are taking a aliphatic amine, then it is observed that aliphatic amine react with a water molecule. Suppose I have aliphatic amine, and as aliphatic amine I have taken a primary amine. So this aliphatic primary amine is taken by me. Just I will write here, it is aliphatic. Now aliphatic primary amine is taken by me. It allowed to react with the water molecule. It donate electron pair. Therefore we are getting a ammonium cation, NH3 plus and OH minus. It giving us ammonium cation. Now positively charged species whatever obtained to us is known as ammonium cation. So aliphatic primary amine on reaction with water molecule giving us ammonium cation. Now suppose I have a aniline, and aniline is allowed to react with the water molecule. Then it is observed that when aniline reacting with the water molecule, it giving us anilinium cation. In this acidic medium or in basic medium, we are getting a anilinium cation. So now whatever anilinium cation we are getting, it is observed that anilinium cation will be obtained. Now whatever anilinium cation obtained, it has a resonating structure. Now what are the resonating structure? The place where posit double bond converting a single bond, and the place where single bond converting in a double bond. So it is observed that anilinium cation whatever obtained to us, it has a resonating structure. Similarly, you are knowing that aniline have also resonating structure. When we take aniline alone, just I have taken aniline alone, then nitrogen of aniline donate electron pair to carbon, and this electron pair will shift on a ortho position. When it shift on ortho position, then we get this type of resonating structure. This two double bond remain as it is, and here double bond positive charge and negative charge. So this is the resonating structure of aniline. This is the first structure. Now this is the second structure. Now further, suppose this bond broken and electron pair transfer here, then we get this another resonating structure, and we can write this structure in this way: double bond remain as it is, NH2 plus, and here now we are getting a negative charge. Electron pair, nitrogen has given electron pair to carbon, so this bond broken, electron pair come on this. Now this carbon give electron pair to this carbon, and bond broken, electron pair come on a para positions. So now this is a third resonating structure. Now suppose this bond broken, electron pair transfer on here, and double bond form between these two carbon, then we are getting this type of resonating structure. We are getting this type of resonating structure. And last, once again, bond broken, and we are getting this type of resonating structure. Now these two double bond remain as it is. This bond break and electron pair will come on between these two carbon. So as a result, you can observe these things. We are getting total 5 resonating structure. Out of this 5, first and last structure, you can observe this first and last structure is calculus structure. So because of this thing, amine, aniline having a 5 resonating structure. In aqueous solution, it gives anilinium cation have also 2 resonating structure. So because of this, non-bonding electron pair will be not present on nitrogen. Therefore, it is observed that aromatic amine are less basic as compared to aliphatic amine. So I will write here one more statement. We can write here aromatic amine are less basic than aliphatic amine, because in aromatic amine, because of a resonating structure, availability of electron pair on nitrogen will be less. Therefore aromatic amine are less basic as compared to aliphatic amine. Now suppose this amine is attached with any group. Now this group having two possibilities. Suppose this group is electron donor group. Then it is observed that when electron donor group is there, then density of electron on nitrogen will increase. So this electron donor group increase. We can write here electron donor group increase basic strength. Electron donor group will increase basic strength of amine. So whenever there is a different type of electron donor group, suppose alkyl group is there or any other chloro group is there, electron donor group attached with this amine, then it will increase the basic strength of amine. Similarly, suppose electron withdrawing group, we can write here electron withdrawing group. Suppose electron withdrawing group is present with on amine structure. Any electron withdrawing group is present, then it has a tendency to take electron from nitrogen atoms. So we can write here decrease basic strength of aniline. Decrease basic strength. So we have to understood electron donor group is present or electron attracting group is present. Suppose electron attracting group like a nitroaldehyde or acetic acid, then this electron attracting group, electron withdrawing group, decrease basic strength of amine. Electron donor group increase basic strength of aromatic amine. So here we have discussed briefly basic strength of amine. Now we stop our lecture at here.